Welcome to lecture 6 of data mining. So today we will wrap up our discussion on data preprocessing. We had spent the last 2 lectures on data preprocessing. We had divided data preprocessing in a number of categories and then discussed some techniques in each of those categories. So in the previous lecture, we talked about data reduction. In which we were trying to reduce the size of the data while preserving the important information within the data. And within data reduction, we talked about dimensionality reduction, we talked about numerosity reduction, and we also briefly talked about aggregation. So today we will talk about data transformation. More specifically within transformation, we'll briefly talk about normalization. And then finally, also quite briefly, we'll talk about discretization. So after that, we will start with a new topic, which is frequent pattern mining or association mining. So which is a major task in data mining. So this would be a basically main task in data mining, not just preprocessing. So, okay, so that's the agenda for today. So as we decided last time, we will have a quiz on Tuesday. We don't have a quiz today. So, and after the quiz on Tuesday next week, we will be having quizzes every Tuesday for at least a few weeks. Right. So as I said, we were talking about data reduction. I just mentioned a couple of things here. So we talked about non-negative matrix factorization last time. So in non-negative matrix factorization, we are getting an approximation of the original data matrix X, which I can call X prime if you like, as the multiplication of two matrices A and B. So the size of A, as we mentioned last time, is n into k, where k is a user-defined parameter. So the parameter k is user-defined and is generally set less than equal to m. M is the number of features. So B is the other matrix, and this is of size k into m. So, and of course, this factorization is done such that the original X and the X approximate that is obtained by the multiplication of A and B should be as close as possible. You can define a loss function like the sum of squared errors between every element in X and X prime. We would like to minimize that. So usually non-negative matrix factorization is an optimization problem. Once you solve that optimization problem, you get the matrix A and you get the matrix B. So now if you look at matrix A, so matrix A is n by k. So this is basically the reduced matrix, where n is the number of observations. Now k is now the features. And of course, these features do not relate easily to the original features in your data set. These are new features. These are embeddings, you can say. But of course, since you have selected k to be less than m, this is a reduced data set. So you can use each row as the observation with k features. So instead of using the original matrix X, you can now use the matrix A for your analysis, for your further computation. So this is the data reduction that is occurring in non-negative matrix factorization. Of course, as the name suggests, non-negative matrix factorization only works on matrices X that do not have negative values. And this is the case for many applications or most applications. So as such, it is applicable. And of course, we previously talked about PCA and SPD and autoencoder. So all of those are dimensionality reduction. Then we talked about sampling for numerosity reduction. So usually we use random sampling in various forms. And then we talked about aggregation. So now let's move on to transformation. So in general, this category says that you are transforming the data. So you have an original data and then you have the transformed data. And this is a category in data preprocessing. Actually, if you think about data transformation in this sense, then many of the techniques that we have already talked about are data transformations. So, but of course, we have this as a separate heading so that you understand that they are techniques that transform the data. So, for example, we did data cleaning, or when we talked about, for example, data reduction, all of that was data transformation. Of course, data integration generally is not transformation unless you change something in data integration as well. So there is another change that can often occur when you construct a new attribute. So attribute construction. So that is also a transformation. So this may arise in some applications where you like to collapse some attributes and construct new attributes from the existing attributes. So you can think of uh, this as manual construction of attributes as opposed to the attributes that are computed automatically by, let's say, PCA. Uh, so, so for example, let's say you can think of an example like, so for example, uh, you have observations of land area, for example, of plots. So maybe all the plots are rectangular in shape. So you record, for example, the length and width. So let's say the length and width are recorded in your database. So instead of using both of these and as required uh, by your analysis, you might want to remove those two attributes and add a new attribute area, which is basically into width. So length into width. So you will remove the original two attributes and add a new attribute, which is area, which is computed as a operation on the values of the other attributes. Of course, you do this yourself based on domain knowledge, not through the process that we found in, let's say, NNMF or PC or SPD. Okay? So this is also transformation. So one category that we have not studied in data transformation is normalization. So this is what we are going to focus on more in this category. So what is normalization? Normalization essentially works on numeric attributes. The idea in normalization is to scale the attributes to appropriate ranges. Uh, and the two or three most popular techniques in this are normalization by min-max and then z-score normalization. These are the two most important. You can also do normalization by decimal scaling. So let's look at these options quickly. So as I said, normalization scales the values to some new range. And generally, in almost all applications, in all cases, you normalize it using a linear transformation. So non-linear transformation is usually not done as part of preprocessing. So usually this is a linear transformation. Okay? So the techniques under this is min-max normalization. So most of you should be familiar with this. So the idea is that, let's say your original data is, let's say, income. So income, let's say, would lie within the interval, let's say 10K to, let's say, 100 or 1000K. All right. So this is the range of income in our data set, and we would like this range to be squashed, or to usually an interval which is between 0 and 1. Okay. So of course this new income is the transformed income. So I can put a star there just to differentiate this new income. Okay. So originally our minimum value was 10 in our database. Our maximum was 1000. Now we like the minimum and maximum to be 0 and 1. So we use a simple uh, linear transformation. So the new value would simply be value minus min divided by max minus min. This is 10 and 1000. Okay. And then you multiply this ratio with the new uh, with the difference in the new max and new min. So new max minus new min. So this is a new range. And then of course, since you are scaling it, you have to start from somewhere, which is the new min. So this formula would give you the transformed value for uh, a particular uh, input value. So for this case, let's take an example. Let's say you want to transform 500 or 50, let's say. So if you want to transform 50, you basically have this formula here, 50 minus what is the min? You have 10, right? Then max and min is 1000 minus we have 10 min, and the new max and min is what? Basically 1 minus 0. So this is the interval, plus you start from 0. So this would give you the value. So 0.04. Does this sound reasonable? 50 का किया था ना हमने. हाँ ठीक है, 50 का किया हमने. So that should be fine. So now the 50 in the new scale would be 0.04. So whenever you do a transformation, sometimes you like to untransform it. So to do that, in this case, you will have to keep the values of the min and max so that you can do the reverse transformation. Let's say you have the transformed value, you like to get the old value, original value. So you can use the same formula and get the original value. But of course, for that, you will have to retain the max and min from your data set that you use to do the original transformation. Okay, quickly, why do we want to do normalization? So why would we like to do normalization? So one of the primary reasons is that if your data set has multiple numeric attributes and each of those numeric attributes have very widely ranging values, then one attribute may overshadow another attribute in some analysis. Let's say even if you are doing visualization, let's say I'm talking about income, एक attribute आपका income था, ऊपर मैंने 10 or 1000 लिखा है, but I omitted the 1000, so 10,000 to 1 million. ठीक है. So income would range from 10,000 to 1 million. So this is a huge range. While let's say in the same data set you have another attribute, let's say age ही ले लेते हैं. ठीक है. So age would range from, let's say, a very small value, let's say 10, 0 ही ले लेते हैं, 0 to about 80. So if you plot this using the same scale, the income attribute, the age attribute would not be even be visible. It would just be a very narrow band of all the incomes over 10,000 to 1 million, because age only ranges between 10 and 80. So if you normalize income to 0 and 1 and normalize age between 0 and 1, and then you do a plot, then you will get a better spread of the data in the 2D plot, and maybe you'll be able to find or discover patterns in a better way. So basically we normalize both attributes to between 0 and 1. So sometimes some algorithms require that your attributes have the same minimum and maximum values, or they are normalized to some ranges. So in that case also you like to do normalization as well. But remember that this is transformation. So you are transforming your original values, and you have to be careful while you're interpreting the final values. You need to know that the values have been transformed, and you should not just directly interpret it before untransforming them, retransforming them. Okay, so that was one method. The other method, which is also quite popular, is Z-score normalization. So in Z-score normalization, so let me use V for the value. So the new value V prime is given by basically this formula V, the old value or the original value, minus the mean of that attribute. So divided by the standard deviation of that attribute. So here the two parameters are the mean and the standard deviation. In the previous case, the two parameters were the max and the min of the original data, and the new max and the new min of the transformed data. Here the two parameters are mean and standard deviation, and if you want to de-transform or reverse the transformation, you will need to maintain or save these values. Okay. So if you subtract a value from its mean, so this is sometimes also called centering. So subtracting from mean. Okay. So numerator में क्या हो रहा है? You are centering the data. So actually, if you look at this data in a plotting sense, I'll show that shortly. You notice that the data axis has been moved to the center of the data cloud. Okay, so this is centering. And then, of course, if you divide by sigma, which is the variance, divide by standard deviation, which is a measure of the spread of the data, you are basically compressing the data to some standard width. Okay, so that's the normalization. So you're first centering and then normalizing by the variance or the standard deviation of the data. Actually, the standard deviation variance is the square of the standard deviation. Okay, so this is also sometimes used for normalizing. In this case, of course, the transform values can in general be from negative. So V prime would in general be actually, in general, it will be from minus infinity to infinity, but of course, they will be in a very narrow band. Outlier हो सकता है very far away, but in general, most of the values would lie between -1 and +1. ठीक है? So after normalization, the values would mostly lie between -1 and +1, and 0 would be the center. Let me. So, so I'll draw a data cloud. So let me draw an axis first. So let's say ये आपका original आपका data है और ये data cloud है. Let's say the data cloud is again उसी time मैं ले लूँ जिसमें PCA के लिए बनाया था मैंने. So this is your data cloud. ठीक है? So now you notice that the mean is somewhere here of X and of course for Y. If you subtract the mean, essentially you are bringing the cloud to the center. आपका cloud अब यूं हो जाएगा, centered हो जाएगा on the origin or of the coordinate system. Because आपने x axis का भी mean, of course this is in 2D, x axis का mean भी आपने subtract कर दिया, y का भी mean कर दिया, तो data cloud has moved to the center of the axis. Of course this would be the same for higher dimensional data set. ठीक है? But now let's say if you also, let's say आपका data cloud यूं है, of course x axis में variance ज़्यादा है, y पे थोड़ा है. अब जब आप standard deviation से divide करेंगे तो ये क्लाउड जो है ना, ये दोनों साइड पे तकरीबन एक ही हो जाएगा, यूं हो जाएगा छोटा, ये कंप्रेस हो जाएगा x वाला, और y वाला पहले ही छोटा था उतना ही हो जाएगा, नॉर्मलाइज हो जाएंगे. तो दोनों ये कम हो जाएंगे, सॉरी जो ज्यादा है वो कम हो जाएगा, दूसरे के बराबर आ जाएगा वेरिएंस. सो बोथ स्टैंडर्ड डिविएशंस वुड बिकम both variance or spread would become the same. बिकॉज इसका जब स्टैंडर्ड डिविएशन ज्यादा था इस साइड का, इससे डिवाइड करेंगे तो वो छोटा हो जाएगा, उसका ऑफ कोर्स थोड़ा था उस साइड पे, तो उससे डिवाइड करेंगे तो उसका उसी का इम्पैक्ट उस तरह पड़ेगा. सो इन अदर वर्ड्स यू आर काइंड ऑफ shaping the data cloud in a more क्या लें कि homogeneous way. So again transformation हो रही है, so you have to be careful if this transformation is uh, is kind of making your patterns difficult to recognize, then it's not recommended. If it is required for your analysis, usually such normalization would be helpful if you do classification, but it would not be helpful if you do clustering or association mining and so on. Okay, because clustering में भी आप पैटर्न ढूंढना चाह रहे हैं स्पेशली, एसोसिएशन माइनिंग में भी पैटर्न ढूंढना चाह रहे हैं, तो दिस काइंड ऑफ नॉर्मलाइजेशन वुड काइंड ऑफ डिस्ट्रॉय दोस पैटर्न्स. ठीक है, एनी क्वेश्चंस? So z-score normalization, you subtract the mean, which is centering of the data, and then you divide with the standard deviation, which means that if there is some axis where is large variance, that would be reduced. If there are some axis with small variance, that would be increased, so that all spread of the data would kind of become uniform. By the way, let's say आपका cloud यूं है, ठीक है? आफ्टर ऑफ कोर्स सेंटरिंग जब कर देंगे तो इसका एक्सिस बीच में आ जाएगा, और आप जब कर देंगे इसको जीस को नॉर्मलाइज कर देंगे, क्लाउड ये ऑलमोस्ट इस तरह हो जाएगा, मतलब यूं करके हो जाएगा, इधर भी स्प्रेड सेम है, इधर भी स्प्रेड सेम है, बट उसका वो वाला पैटर्न फिर भी रहेगा कि इट इज पॉजिटिवली कोरिलेटेड यूं करके है. इसको खत्म करना है तो मे बी यू कैन डू पीसी एनालिसिस और चेंज द कोऑर्डिनेट सिस्टम. If you do that, then essentially you get almost a circular or spherical, hyperspherical data cloud. ठीक है? So let's say आपने जी स्कोर नॉर्मलाइजेशन भी कर ली और फिर उसके ऊपर PCA निकाल के नए कोऑर्डिनेट्स पे प्रोजेक्ट कर दिया. If you do that, if you do all of that, then that is called whitening, because the whole data cloud becomes a sphere, kind of random हो गया, कोई इसमें pattern है ही नहीं. So that's called whitening. And of course, whitening in general is not recommended for many uh, data mining tasks, but you need to know, okay, ये whitening हो गई है. You have removed all significant patterns that you can see in space by first kind of z-score normalizing it and then projecting it onto the uh, principal components. All right, any questions? Okay, the last one, which is actually rarely used in practice, but book mein hai, so let's quickly discuss it. Decimal scaling. So decimal scaling essentially is v prime, the new value is v divided by uh, some constant, ठीक है? A large constant such that the new values v will lie within your desired range. ठीक है? तो ये कांस्टेंट आपने खुद ही डिसाइड करना है. तो यूजली हम ये कांस्टेंट 10 के रेस के पावर ऑफ सम आई ले लेते हैं, बट इट कुड बी सम अदर कांस्टेंट आल्सो. ठीक है? I of course can be an integer, right? So that's why this is called decimal scaling. So आप basically decimal points पीछे लेके आ रहे हैं, but in general it's dividing by a constant. So that constant can be decided um, by your अच्छा, मेरे ऑफिस की खिड़की को पानी का शावर हुआ है. आई थिंक यू मस्ट हैव हर्ड इट. डरा भी देते हैं. ओके. अच्छा. ठीक है. So depending on your, let's take a quick, let's say ये जो income की मैंने पहले example ली थी, income was within the interval 10 and 1000. So one constant that you can use is constant, let's say, is equal to 1000. तो हर वैल्यू को 1000 से डिवाइड कर दें. तो ऑफ कोर्स 1000 वाली वैल्यू तो 1 हो जाएगी, 10 वाली वैल्यू ऑफ कोर्स 0.001 हो जाएगी. ठीक है? So this is decimal scaling. It's less commonly used. The two most common are min-max normalization as well as z-score normalization. By the way, min-max normalization जो ऊपर हमने बताई थी, you can choose your own min and max. They could be anything. Usually जैसे मैंने कहा ये 0 और 1 है, but आप -1, -1 और 1 भी ले सकते हैं, +1 या कुछ और ले सकते हैं, 50 to let's say 100 ले सकते हैं. So that's up to you. Z-score normalization में of course primarily -1 to 1 तक final values हो जाएंगी. Okay, so that was normalization. So now let's move on to the last part, which is discretization. So discretization is essentially applied to numeric attributes again, and the idea is to convert values to labels. ठीक है? And of course, this can also be considered as a data reduction approach, where the number of distinct labels is reduced. So, and why would you want to do discretization? Meaning that you're converting from numeric attributes to categorical attributes. You're giving labels to them instead of numbers. Okay? So why would you want to do that? Of course, one thing that you like to do is, of course, for data reduction, and you want to improve the visualization of your data through some labels. But there are some techniques that work only on numeric or work only on categorical data. So for such techniques, you will have to convert your numeric data to categorical data. Okay? So one common example that is cited is decision tree algorithm. So decision tree algorithm work best when your data set is categorical, not numeric. और जो भी आप एल्गोरिथम पढ़ते हैं डिसीजन ट्री लर्निंग के लिए उसमें न्यूमेरिक एट्रीब्यूट्स होते हैं लेट्स से वो एक्सप्लिसिटली आप डिस्क्रिटाइज नहीं करें तो इम्प्लिसिटली वो कर रहा होता है विद इन द एल्गोरिथम. ठीक है. सो इसमें देयर आर बंच ऑफ टेक्निक्स हियर एज वेल ऑफ कोर्स उनको we will just quickly discuss some of them. तो उसकी कुछ categorization कर लेते हैं. Some of them are based on machine learning, others are purely algorithmic. So based on machine learning, we can say that they are supervised, they can be supervised versus unsupervised. Actually, I shouldn't call them machine learning, actually supervised in the sense that they are, the discretization is based on some uh, information, while some information that is not part of the discretization. While in unsupervised, we do not rely on that additional information. You can relate it to machine learning as well, but I think it's better not to because machine learning में और चीजें भी होती हैं regarding supervised and unsupervised. The other way of categorizing such techniques is that it can be top down versus bottom up. So for example, in this later case, so top down में क्या होगा, let's say आपके पास original values हैं, उनको आप split करके intervals में बना लेंगे और आपके पास लेबल्स बनते जाएंगे. बॉटम अप में इंडिविजुअल वैल्यूज को आप मर्ज करते जाएंगे तो लेबल बनाते रहेंगे. तो लेट्स क्विकली लुक एट सम ऑफ दीज टेक्निक्स. अच्छा, तो सो द मोस्ट कॉमन टेक्निक दैट इज यूज्ड दैट इज बिनिंग. बिनिंग हमने पहले भी पढ़ा हुआ है. ठीक है. सो बिनिंग वाज यूज्ड फॉर स्मूथिंग एंड डेटा क्लीनिंग. नाउ you can use binning for discretization as well. So binning can be done using equi-width or equi-depth binning. We discussed this before as well. The idea then is, let's say आपके पास कोई bin कोई कोई let's say आपके पास कुछ numbers हैं 1 3 and let's say 6 and 10 and let's say 11. तो आप let's say दो bins इसके बना दें equi bins. So equi-width 10 minus 1 10 बनता है तो 5 का 1 plus 5 6. So 1 to 6. Okay. So basically we have the interval is from 11 to 1, so which is of course 10. Okay. And let's say if you want two bins, let's say two bins, each bin would be of size 5. So 10 over 2, 5. Okay. So first bin will be from 1 to 6. Again, you have the boundary issue here. The second one would be 6 to 11. ठीक है. सो अब आपके पास जितनी भी वैल्यूज हैं पहले बिन में उसको आप लेबल दे सकते हैं. सो फॉर एग्जांपल पहले बिन में आपके पास 1 3 5 6 था. सो पहले बिन में वैल्यूज कौन सी आ रही हैं. सो यू कैन से 1 3 5 एंड 6. दिस इज इन द फर्स्ट बिन. So instead of retaining these values, just give them a label. So maybe आपका label based on your domain knowledge might be small. Let's say एक label दे दिया small. So each of these values would then be small. ठीक है. पहला भी small है, दूसरा भी small है, तीसरा भी small है, and so on. ठीक है. ये सारी values there is a reduction in values and you have assigned label. जहाँ भी आपको कोई वैल्यू नजर आएगी between 1 and 6 उसको small कहेंगे आप. इसी तरह आपकी वैल्यू जो between 6 to 11 है वो आप बेशक लार्ज कोई और लेबल असाइन कर दें, लेट्स से लार्ज. तो लेट्स से आपकी वैल्यू जो 10 है, दिस वुड देन बिकम लेट्स से लार्ज. ठीक है. So now you have converted your data into categorical labels, discrete labels. So you can do this, as I said, by equi-width, which is more common, or you can do equi-depth as well. So this is unsupervised. कोई हमने external information नहीं ली. और this is also top down, meaning that पहले सारी आपने values रखी, उनको split किया, कुछ intervals बनाए, तो वो आपके labels बन गए. And you can do it recursively. So for example, जो आपके पास एक इंटरवल बन गया था, लेट्स से 1 to 6 वाला इंटरवल, इसको फर्दर भी आप डिवाइड कर सकते थे इफ यू वांटेड टू. तो मे बी आपके पास 1 to 3 हो जाता एंड देन 3 to 6 दूसरा हो जाता. ठीक है. सो यू कैन डू रिकर्सिवली ऑन ईच ऑफ दोज. 1 to 3 को फर्दर कर लेते, 3 to 6 को फर्दर कर लेते, यू गेट ए ट्री स्ट्रक्चर. ठीक है. So and then of course you can assign labels to them as uh, appropriate for your application or domain. So this is unsupervised top-down. So let's briefly look at supervised. Supervised में mostly जो use होता है वो entropy based होता है approach. So of course इसमें आपको supervision चाहिए. So let's say if you want to discretize let's say age, ठीक है. Age might not be a good um, so you will be discretizing a continuous attribute using some label that is appropriate for that attribute. So so let's say your continuous attribute is height, okay? And the label that you use for discretizing this is let's say examples कोई इतनी अच्छी नहीं आ रही. Right, so let's use a more simpler example. Age or let's say student rank, ठीक है? So age of course is student age and rank मतलब ये है कि वो freshman है, sophomore है, junior है, so on. So based on that label, which is of course rank is basically a categorical attribute, उसको लेके आपने एक continuous attribute को discretize करना है. Since we are using another attribute to discretize another attribute, this is supervised. So इसमें हम entropy use कर सकते हैं. So entropy हमने पहले introduce नहीं की थी, but we will be talking about entropy later as well when we discuss decision trees. So essentially हमने ये करना है कि so let me take an example. Let's say आपके पास 18 है और 19 है age. अच्छा. So junior, freshman, sophomore, 2 साल ले लेते हैं हम. So let me write the so this is freshman, 18 freshman, 19 let's say junior, 19 freshman. So let's say we have two possible labels. So what we do is we rank the numeric attribute as we have done this. We have ordered it. 18 पहले लिखा, 18 लिखा, 19 लिखा, 19 लिखा, and उसके corresponding जो भी इसका label है. So what we now do is whenever the label changes, so that is a potential split point. So let's say जो पहले दो 18 जो थे वो फ्रेशमैन थे, ठीक है, और यहाँ 19J है, so we have a split point at F and J which is 18 and 19. So 18 and 19 पे एक split point है. अब वो split point के कई options हो सकते हैं. एक तो ये split point option है. अब यहाँ भी एक split point आ रहा है because यहाँ हम आपके पास J है, junior है, और फिर freshman आ गया. So we have a split point between 18 and 19 and between 19 and 19 also. दोनों वो 19 है by the way. ठीक है, अब इसमें से कौन सा बेस्ट होगा? वी यूज एंट्रोपी, वी कंप्यूट द एंट्रोपी ऑफ बोथ सिनेरियोज बिफोर द स्प्लिट एंड आफ्टर द स्प्लिट, और जिसकी एंट्रोपी सबसे थोड़ी है दैट इज द फर्स्ट स्प्लिट दैट वी मेक. सो लेट्स से इफ यू मेक द स्प्लिट एट द फर्स्ट केस विच इज 18, और 18 एक हो गया और दूसरा 19, 19 दूसरा हो गया, तो देन वी कैन गिव दिस वन कॉम्बिनेशन एज ए लेबल. ये एक लेबल बन गया, एक इंटरवल एक लेबल हो गया, so दूसरा भी एक इंटरवल आपका एक लेबल हो गया. एंड ऑफ कोर्स हियर अगेन यू कैन डू इट रिकर्सिवली. जो पहला इंटरवल था 18 इसको फर्दर आप स्प्लिट कर सकते हैं इफ देयर इज अ डिफरेंस इन द लेबल्स देयर. इन दिस पर्टिकुलर केस एक्चुअली देयर इज नो डिफरेंस, दोनों 18 FF है, तो देयर इज नो पोटेंशियल फॉर स्प्लिटिंग दिस. ठीक है, सो ये जो स्प्लिटिंग का क्राइटेरिया, दिस इज ऑलमोस्ट आइडेंटिकल टू द डिसीजन ट्री लर्निंग एल्गोरिथम. डिसीजन ट्री हम पढ़ेंगे आगे जाके, सो दैट्स व्हाई आई एम नॉट कवरिंग इट हियर. So, but just wanted to mention that you can use this to discretize uh, continuous attributes, and this is called supervised, and it is top down. मतलब splitting हो रही है, not merging. ठीक है? So एक और supervised approach है which is based on merging, which is less commonly used. Merging मतलब is bottom up is the chi-merge approach. So chi-square को use करके again you need a class label and original attribute of chi-square compute करके you merge attributes, merge values. So it's the opposite of splitting. So why when would you merge two values? When the chi-square is large. ठीक है, मतलब वो दोनों एक ही ग्रुप में आ रहे हैं, तो chi-square large क्या होता है? They are related. If they are related, then you merge them. ठीक है, so these are the primary techniques. Binning is the most popular, then supervised में of course entropy is the most popular. Chi-square is not much used. ठीक है, okay, then finally very briefly about I think that's pretty much it. So I think we have come to the end of this chapter. So in data pre-processing, we had discussed various categories of techniques. Within each category, we talked about some approaches. And idea was that we are not, the idea was to give you a survey of what is available. It's not that you will be applying all of these for all of your tasks. You have to select the ones that is most appropriate for your task. Okay. Any questions? Okay, no questions. Okay, so now let's move on to frequent pattern mining. So this is a major task or functionality in data mining. So remember that we discussed functionalities in the first couple of lectures. So one of the functionalities was frequent pattern mining. So now we are going to discuss this functionality in more detail and discuss some algorithms within this category of functionalities, within this functionality. Uh, so frequent pattern mining is actually a descriptive mining technique. Descriptive mining is not predictive. Of course, you can use the results of this frequent pattern mining for prediction, but primarily it is descriptive in nature that given a data set, it will tell you something about the data. So it describes the data. Okay? Of course, using that information, you can build a predictive model, but the primary goal of frequent pattern mining is to describe the data, find out hidden nuggets of information within the data. Yeah. So what is a frequent pattern? So first of all, what is a pattern? So pattern generally is a regularity, some structure, uh, some regularity or structure in the data. And what we are interested is frequently occurring such structures or regularities. And the idea in frequent pattern mining is given a data set, we would like to find what are the frequently occurring patterns in the data. Of course, patterns, as I said, regularity or structure would vary according to the data type. So if your data type is sequence, data type is a sequence database, the patterns would be of sequences or sequential rules, for example. If your database is a transactional database, then your pattern would usually be a set of items or set of events. If your database is graphs, then the pattern may be subgraphs of interest, like cliques. Cliques are fully connected components in a graph. But in all of these cases, what we are interested in is those patterns that occur frequently in data, that have a occurrence that is greater than some user-defined threshold. Okay. So it has applications in many domains. The most popular application, of course, is market basket analysis. So market basket analysis, we have talked about this previously as well. Essentially, when you go to a grocery store, you pick up a basket and you buy a number of products. So those items that you buy or check out at any given point in time, which is a transaction, of course, uh, is it's a transaction, but that's a one transaction. And in a database, you'll have hundreds and thousands of transactions. From those hundreds and thousands of transactions that consist of items bought together, we would like to find what items are frequently bought together. Okay? For example, I don't know how familiar you are. If you go to Amazon.com and go to any products page, you will also see somewhere below there that frequently bought with. So there are some recommendations that are made by Amazon that if you are looking for to buy this item, others people have bought this along with others as well. So how did they find those other items? By doing frequent pattern analysis. So if your data set is sequential, you can predict also what would happen in the future. So if there is a frequently occurring event after a given event, so that's also a structure that you can find through frequent pattern mining. So for example, if someone bought a PC, uh, or let's say if someone bought a mobile phone today, that person may come back maybe in a week or a month to buy, let's say, a charger, for example. Okay? So if this pattern that someone bought something today, which is a mobile, and then a charger later on, is frequent, and this is an important piece of information. So most of this application that is mentioned here comes from the business domain, retail sector. Basically, cross-selling is also when you buy one item, you can recommend something that has been bought by others that is from a different line of items. For example, if you're looking for clothing and based on your analysis, someone who has bought clothing also buys, let's say, shoes. So that would be uh, a useful pattern and you can use it for cross-selling. So again, of course, I think all of these things are now widely used in practice, especially on e-commerce. On the website, Amazon is a very good example of using such tactics to sell new items to you. All right, so now let's try to formalize this problem more precisely. So let's look at the basic concept. So any questions? So let's take this simple example of market basket analysis. Okay, and so here our pattern is a set of items which you purchase at any given point in time. Okay, and let's use this as our starting example and use this to build our algorithms. And then later on, we will see that by slight modification, you can use this same idea for sequential pattern mining, for graph pattern mining. Okay, so 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 let's say I have a transactional database of transactions. So let's say the first transaction is, let's say you bought milk and butter. The second transaction is bread and milk, okay, and butter. The third transaction is, let's say, butter. The fourth transaction is, let's say, milk. Of course, very simple example. Of course, you'll have hundreds and thousands of transactions even per day at major retail stores. So this is a very small example. So in this case, we have a transactional database. Each row is one transaction, and each row consists of a set of items, in this case, products that are bought together. Okay? So this is a set. There is no notion of order within those items. And secondly, as you can see, any one transaction may consist of one or more items. Okay? So there isn't any fixed number of items. So you can have one item or you can even have 10,000 items. Okay. Now, given this basic framework, what we are interested is we want to find uh, items as well as item sets in general. So, for example, in this small database, what are the items? You have milk, you have butter, you have bread, and okay, यही है मेरा. So distinct items are, so milk, butter, and bread. ठीक है? So, and of course, these are also the single items, but you will also have higher order item sets. So you have the combination milk, butter, you have the combination milk, bread, you have the combination bread, butter. So these are the two item sets. Items that are sold, two items that are sold together. And then of course you also have the three, which is of course milk, bread, and butter. Okay? So all of these are what we call in this terminology as item sets. ठीक है? एक ही हमने इकट्ठा लफ्ज बना दिया, item और set इकट्ठा कर दिया. And this could be one item or more items. So we usually say that, in general, we say that K item set. So it could be a one item set as well. So one item set का example क्या होगा? Milk. So this is a one item set. So butter is a one item set. So what would be an example of two item set? So for example, milk and butter together, this is a two item set. And let's say butter and bread, this is also a two item set. And three item set would be all three things. ठीक है? Milk, butter, bread. Okay, so now the question is, given such a transactional database and you have an idea of sets of items, I would like to find the most frequent sets of items. They could be one item set, they could be two item set, they could be three item set, they could be higher. In this case, of course, three से ज़्यादा हो नहीं सकता. ठीक है? So frequent का आप notion किस तरह define करेंगे? If it occurs more than some minimum number of times in the database. So we call that support. What is the support of an item in a transactional database? ठीक है? Support is essentially the okay. So basically, this is the you can say fraction of times an item set occurs in transactional database. Okay. So let's just quickly look at our transactional database. So first of all, हमारे transactional database में कितनी transactions हैं? 4 हैं. 1, 2, 3, 4, right? हमारे पास distinct items कितनी हैं? 3 हैं. Milk, bread and butter. ठीक है? So let's say मैं आपसे पूछता हूँ, how many times did milk and butter occur together in this database? So it occurs here. So this is one transaction. This is 2. इधर भी milk butter आ रहा है. ठीक है ना? इधर नहीं आ रहा, इधर भी नहीं आ रहा. ठीक है? So milk, butter की काउंट क्या है? 2 है. So 2 is the count. इसकी सपोर्ट क्या होगी? 2 divided by 4, 0.5. We can also say this as 50%. So 50% of this transactional database has this combination milk and butter. ठीक है? So now among all the possible item sets, we would like to find those that are frequent. And how do you know it is frequent? Because we have specified some limit. Let's say हमारे limit 50% ही था. So I want to find all item sets, frequent patterns or item sets in this case, that occur 50% or more in my transactional database. So in this case, of course, a small database, आप quickly देख सकते हैं. Milk butter तो हमने अभी calculate कर लिया आ रहा है. ठीक है? Are there any other two item sets that occur?
No, sir.
और कोई two item set नहीं है because यहाँ भी एक है. ठीक है? इधर भी एक है. इसमें for example जो milk और butter है या milk या bread है, it only occurs once. ठीक है? So both of these would have a count of less than 50% or count of less than 2. ठीक है. एंड ऑफ कोर्स ये जो 3 आइटम सेट है, दिस आल्सो अकर्स वंस. सो हमारे पास जो 2 आइटम सेट जो था, दैट अकर्स फ्रीक्वेंटली इज ओनली मिल्क एंड बटर. 1 आइटम सेट क्या है? मिल्क कितनी दफा आ रहा है?
3 times.
मिल्क 3 टाइम्स आ रहा है. ठीक है. सो 3/4 75%. व्हाट अबाउट ब्रेड?
Only once.
ब्रेड एक दफा आ रहा है, तो वो फ्रीक्वेंट नहीं है. ठीक है. व्हाट अबाउट बटर? Butter occurs also 3 times, right?
Yes, sir.
So butter is also. So now we have actually, for this small data, we've done this manually. But can you do this manually for larger data sets? So first of all, so let me kind of formalize this a little bit. Uh, so we have a transactional database. Okay. We have n transactions. Okay. Total number of transactions is n. Okay. And then we have what is known as a set of items I, set of possible items. ठीक है. So I1, I2 to IM. In our case, it is milk, bread, and butter. So 3 थी. But in general, there could be M items, possible items for which sets can occur. ठीक है ना? So any particular transaction, so let's say transactional database में जो लिखा था, and is basically a set of transactions T1, T2, T3 to Tn. ठीक है. Where any Ti is coming from I. Do you understand this? एक रो जो थी उस ट्रांजैक्शनल डेटाबेस पे, it could be is basically a subset or equal to I. इसको सबसेट करना चाहिए. सबसेट वाला नोटेशन क्या है? सबसेट इक्वल टू. सो दिस इज द वो जो लेटा हुआ u विद ए अंडरलाइन, इक्वल भी हो सकता है. ठीक है. सो फॉर एग्जांपल, एक हमारी ट्रांजैक्शन ऊपर थी जिसमें मिल्क, ब्रेड, बटर तीनों थे. आई में भी मिल्क, ब्रेड, बटर है. एक हमारी ट्रांजैक्शन मिल्क है, विच इज वन आइटम फ्रॉम आई. और एक ट्रांजैक्शन थी जिसमें सिर्फ मिल्क और बटर था, विच इज ऑल्सो ए पार्ट ऑफ आई. ठीक है. एंड ऑफ कोर्स योर ट्रांजैक्शनल डेटाबेस इज a collection of such transactions. So now given this, we would like to find all item sets that have support greater than some minimum support specified by user. ठीक है. So this is a parameter. इसको generally इस literature में हम generally min support कहते हैं, min sub. ठीक है. Minimum support. All right. So now coming to this example, back to example again. So let's say आपके पास m items हैं. So m items की कितनी वन combinations होती हैं आपके पास? मतलब of course one, of course m ही होंगी ना. और इसको हम जनरलाइज करें तो क्या बनता है, इसको हम किस तरह लिखेंगे? m आइटम्स है आपके पास, ठीक है। सो 1 आइटम सेट्स कितनी होंगी? वी से दैट m choose 1, right, which is of course equal to m. What about 2 item sets? M choose 2, right, which is going to be a bigger number. And 3 item sets, M choose 3, which is again going to be a bigger number. And so on. तो ये जो सारी हमारे पास आइटम सेट्स हैं, इन सारों में से लार्ज नंबर ऑफ आइटम सेट्स निकलेंगे, सारों की हमने काउंट करना है, सारों का हमने चेक करना है मिनिमम सपोर्ट से ज़्यादा है कि नहीं है. So for most practical cases, you can't do this in a brute force way. ठीक है. So just to by the way, ये सारी जितनी भी बनेगी ये पावर सेट होगा. So पावर सेट इसका कितना होता है? 2 raised to power of m. सारों को आप ऐड कर दें, 1 आइटम सेट, 2 आइटम सेट, 3 आइटम सेट, अप टू m आइटम सेट्स. ठीक है. That is equal to the power set, right? So power set is 2 raised to power of m. Okay, m का साइज टिपिकली क्या होगा? लेट्स से आप ये कार4 ही ले लें यहाँ का. How many items does car4 sell? Car4 sells, like, I would say easily tens of thousands of items. So 2 raised to power of 10,000 कितना होगा? ये तो मेरा कैलकुलेटर निकालेगा भी नहीं. ओहो, सो गया. ठीक है, तो उसने इन्फिनिटी कर दिया इसको. ठीक है. सो इट्स गोइंग टू बी अ मैसिव मैसिव नंबर. अब इस मैसिव नंबर को आपने काउंट करना है, इवन सेव भी करना है, इट्स नॉट पॉसिबल. उसके बाद काउंटिंग करनी है, इट्स नॉट पॉसिबल. एंड देन यू हैव टू चेक व्हाट इज द मिनिमम सपोर्ट. So this is where the challenge arises. We want to devise efficient and scalable algorithms that can find all frequent patterns in a transactional database, all frequent item sets in a transactional database. ठीक है. So this is what we'll be discussing in the next class. I think I will stop here. So any questions?
Yes sir, I have one. तो
ये जी.
मुझे ये चीज समझ नहीं लगी कि इसके अंदर k की सिग्निफिकेंस क्या है. फॉर इंस्टेंस कभी मैं k 1 से लेकर m तक चूज कर सकता हूँ, लेकिन एसेंशियली जब आप क्लोजर टू m जाते रहेंगे तो आपके ऑफ कोर्स नंबर ऑफ कॉम्बिनेशंस इंक्रीज हो जाएंगे, लेकिन उनकी यूटिलिटी नहीं रहेगी. आई मीन वो m, फॉर एग्जांपल अगर आप m कॉम्बिनेशन m यूज करते हैं तो बहुत कम होगा कि वो कॉम्बिनेशंस रिपीट होंगे इन द ट्रांजैक्शंस लेटर ऑन. तो फिर हम लोग उनको क्या डिस्कार्ड कर देंगे या उनको हम यानी कि कंसिडर करेंगे ही नहीं?
एक्चुअली आपने वही जो जो एल्गोरिथम्स, एफिशिएंट एल्गोरिथम जो आइडिया यूज करते हैं उसी की बात की है. So the efficient algorithms take this into account and try to start with 1, 2 and 3, and they will find out that higher order पे जा रहे हैं तो उनके counts ही खत्म हो जाते हैं, so they stop. तो पूरा brute force उनको करने की जरूरत ही नहीं है.
ठीक है, मेक सेंस.
तो यही अब idea एक, this is one of the idea that the algorithms use, and we will discuss this in the next class. So which is of course called the a priori algorithm. By the way, आपको शायद मैंने ये पहले भी बताया था कि data mining as a field became really popular after the discovery of this problem. So statistics पहले भी थी, machine learning पहले भी थी, but ये जो specific problem है, this is unique to data mining. मतलब data mining की field is defined by this problem. ठीक है. बाकी problems of course classification, clustering वो पहले भी थी, but data mining में ये frequent pattern mining ये data mining ने introduce की है. So this problem was, I think, actively researched in the early 1990s. And then in 1993, 94, the algorithms were started efficient algorithms were developed for this. And then we had people that had applied this algorithm in their various businesses. So we had examples from Walmart and so on in those times in the middle 1990s who used this idea to promote their businesses. Okay. So any other question? Any other question? No questions? ठीक है तो इंशाल्लाह फिर ट्यूसडे को हमारा क्विज होगा आज हमने नहीं किया सो फ्रॉम ट्यूसडे को क्विज होगा फिर फॉलोइंग ट्यूसडे को भी होगा सो क्विजेज में जैसे मैंने कहा था कि जितना मटेरियल पिछली क्लास तक हो चुका है जैसे आज तक हो चुका है वो फिर ट्यूसडे तक आ सकता है चेक हो सकता है ऑफ कोर्स आफ्टर द प्रीवियस क्विज